Welcome to the presentation of the R3201 Reset Timer IC. Reset Timer ICs are targeted for portable devices with internal batteries, requiring the possibility to reset the software in case of a software malfunction. It can be used in portable medical devices, cameras, mobile phones, tablets, wearables, portable game consoles and music players. We would like to explain why a reset timer is needed and what kind of issues are addressed. Due to the complex level of functions available on portable devices, there is a possibility that it may lock up due to a software malfunction. In such case, one has to initiate a reset cycle to return to normal operation. It can be done in several ways, like pressing a dedicated reset switch or by holding two available buttons for a certain time. The R3201 detects a reset request and provides a reset cycle to an application processor. Another important feature of the R3201 is the shipping mode. This kind of operation mode is very useful when the device is stored in a warehouse for a long time or during a shipment. Devices with internal or pre-installed batteries that are stored for too long in standby mode will drain the batteries and may be completely exhausted before being delivered to the customer for initial use. The IC has a number of control pins explained one by one. It has two independent reset request inputs called RST0 and RST1 to connect a single reset switch or by using two available device buttons. Both inputs have an incorporate debound circuit with a delay time of 10 milliseconds. In order to prevent an accidental reset cycle, these switches need to be activated and held for a certain period. One is able to select from an optional 8, 10, 12 or even 16 seconds delay time, which is internally fixed by product version. Once the reset cycle is triggered, it will provide an actual reset period of 0.4 seconds, controlling the SRO and NSRO outputs. Additionally, the R3201 has two N-channel open drain discharge outputs available called Discharge 1 and Discharge 2. The purpose is to discharge output capacitors to ground during the reset cycle, ensuring that the power lines are completely de-energized. The application processor is able to send a short clock pulse signal to the off input pin, and the R3201 will switch to the shipping mode after 15 seconds. As a result, the SRO output will control an external MOSFET, disconnecting the battery line from the circuit, and in this way the off-mode leakage current is avoided and prolongs battery life significantly. The output even has a specific slew rate in order to switch the power supply smoothly. The second NSRO output is used, for example, to control an LDO or DC-DC converter to the standby mode. The shipping mode is released by activating the power on button for more than 2 seconds or by applying a power adapter to the device detected by the TANE input. This input has a breakdown voltage of 12 volts but can be extended to 30 volts by adding a series resistor of 100 kilo ohm. In the shipping mode, all redundant circuits are isolated from the power supply and the remaining current consumption is decreased to a minimum. On this slide, a comparison is shown between a conventional circuit and a solution with the R3201. The conventional circuit is a simple solution, providing a reset cycle only when the two RST inputs are activated. On the other side, a much more advanced solution, including the same reset feature, but also an additional shipping mode and two discharge outputs. Despite the additional features, it still requires only a few extra components. The R3201 operates on a supply voltage from 2.2 to 5.5 volt and operating temperature range is from -40 to 85 degrees Celsius. Current consumption of the R3201 is only 0.35 microamp. The reset request delay time is internally set and one can select from 4 different product versions. A small wafer-level chip-scale package is used for this product and occupies only 1.4 by 1.8 mm board space and has a height of 0.4 mm.